40,000 tables in Snowflake, a business glossary with 600 terms, column level lineage across every pipeline. And still, when a new analyst joins the team and asks, "Where's the customer data?" the honest answer is, it depends on what you mean by customer. That's the gap between having metadata and having meaning. Most data catalogs do an excellent job of indexing what exists. They can tell you this table has 12 columns, it was last updated Tuesday, and it feeds 3 dashboards. What they struggle with, what nearly every data team struggles with, is capturing the semantic relationship between things. Not just that a table exists, but what it represents. Not just that data flows from point A to point B, but what that data means at each stage. That gap has a name. It's the gap that ontology and context graphs are designed to close. And right now, with AI tools depending on semantic context to generate anything trustworthy, closing that gap has moved from theoretical to urgent. This guide breaks down what ontology and context graphs actually mean for data practitioners, not the philosophy department version, the working with data everyday version. We walk through how Atlan's metadata architecture maps to these concepts, where the platform is today, and how teams are building towards semantically rich data environments without waiting for a perfect model. We've watched teams invest months building glossaries that end up abandoned, in lineage graphs that answer where but never what it means. The practitioners who get ontology right don't start with a grand theory. They start with one domain, a handful of core concepts, and a platform that lets those concepts connect to real assets. That's exactly the approach this guide follows, grounded in Atlan's actual capabilities, honest about where the edges are. Every modern data catalog starts with good intentions. The team connects their warehouse, their BI tools, their transformation layer. Assets flow in, thousands of them. The catalog builds lineage graphs, indexes column names, maybe even auto generates descriptions. On paper, the data estate is documented. In practice, something is missing. What we're looking at is a flat inventory. Every asset is a peer of every other asset. There's no structure that says these 15 tables all relate to the concept of customer, or this column called rev in the finance schema means net revenue after returns, while rev in the marketing schema actually means gross attributed revenue. The catalog knows what exists, it doesn't know what anything means. In Lineage, as powerful as it is, only partially solves this. Lineage tells us that the raw customer staging table feeds the customer dimension table, which feeds the monthly revenue report. That's the flow. But it doesn't tell us that somewhere in that pipeline, customer shifted from meaning anyone who created an account to anyone who completed a purchase. The technical transformation is visible. The semantic transformation is invisible. This is what we call context poverty. The data estate grows richer in volume and poorer in understanding. Teams compensate with tribal knowledge, Slack threads, and documentation wikis that go stale in weeks. New team members spend their first month not learning the tools, but learning what things mean by asking people, not by consulting the catalog. Three forces are making this unsustainable. First, scale. When a catalog holds 50,000 assets, browsability collapses without semantic structure. You can't scroll your way to understanding. Second, regulation. GDPR, CCPA, the EU AI Act, all of them require organizations to demonstrate not just what data they have, but what it represents and how it connects to real world entities. An auditor doesn't want a list of tables tagged PII. They want proof that the organization understands every asset that represents a patient, a customer, a financial counterparty. Third, and this is the one accelerating everything, is AI. Large language models generating SQL, answering business questions, automating classifications, all of them need semantic context to be trustworthy. Without it, they hallucinate all the time. An AI tool that doesn't know the difference between gross and net revenue will confidently give the wrong answer. The flat catalog was the right starting point. It's not the destination. Building on that foundation of what's missing, we can define what fills the gap. And we should start by diffusing the word ontology because it carries more academic baggage than it actually deserves. In data management, an ontology is a structured model of meaning. It defines the types of things that exist in a domain, the properties those things can have, and the relationships between them. That's it. Not philosophy, not abstract theory, a working model of what an organization's concepts are and how they connect. Most data teams already have the first level, a glossary. Some have the second, terms organized into domains or categories. Very few have reached the third level, where concepts carry typed relationships. Here's what the difference looks like in practice. A glossary entry for customer is a definition, an individual or organization that has purchased a product or a service. Useful, static. An ontological model of customer says customer is an entity. It has properties, name, segment, region, acquisition date. It has relationships. A customer places orders, belongs to an account, is served by a sales region. It has constraints. Every customer must have at least one contact. And it has subtypes. Retail customer and corporate customer inherit base properties but add their own. That model isn't just documentation, it is operational. When a new table appears that contains customer data, the ontology tells the system what properties to expect, what classifications might apply, and what other assets this table is semantically related to, even if no one has manually tagged it yet. Now, a context graph. If an ontology is the model, a context graph is the model applied to real assets. A context graph surrounds every data asset with the full web of metadata relationships that give it meaning. Its lineage, its glossary terms, its classifications, its owner, its usage patterns, its quality scores, its domain memberships. All of it connected. Lineage is one thread in this fabric. The context graph is the entire fabric. When we say a platform supports context graphs, we mean it can surface, connect, and reason across all of these relationships simultaneously, not just show them in separate tabs. And this is precisely why AI is making ontology urgent. When an AI data assistant receives the question, "What was last month's revenue in EMEA?" it needs to resolve several things. Which table holds revenue? What is the definition of revenue? Gross, net, or GMV? What does EMEA map to? A region column, a filter value, a separate schema? An ontology provides these answers. Without it, the AI is pattern matching on column names and hoping for the best. Now that we've established what ontology and context graphs are, we can examine what Atlan actually provides and how those capabilities map to the model we described in the previous section. Atlan's metadata platform is built on a graph-based store. Entities, tables, columns, dashboards, users, glossary terms are stored as nodes. Relationships, lineage, ownership, classifications, glossary linkages are stored as edges. This is architecturally significant because it means Atlan is already operating a metadata graph. The question isn't, does Atlan have a graph? It's how rich, typed, and semantically expressive can that graph become? Let's walk through the building blocks. The business glossary is Atlan's most direct ontology primitive. It supports terms organized into categories and relationships. A team can define customer nested under the core entities category and create related terms like retail customer and corporate customer. Crucially, glossary terms link to physical assets. The term customer lifetime value can be connected to the specific columns across multiple warehouses where CLV is calculated. This is the bridge between business meaning and physical data that most organizations are missing. Now, custom metadata extends what we say about an asset. Atlan allows teams to find their own metadata attributes, such as business criticality, and attach them to any entity. In ontology terms, custom metadata is how we annotate nodes with specific properties that the default schema doesn't include. It's extensibility without schema migration. Classification and propagation are where things get interesting from an ontology perspective. When a column is classified as PII in Atlan, that classification can propagate through lineage. Downstream columns that inherit from a PII source automatically receive the classification. This is a primitive form of ontology inference. A full ontology engine would generalize this pattern. Any property could propagate based on defined schematic rules, not just classification tags. But classification propagation demonstrates the principle: metadata that is active, that follows relationships, that derives new facts from existing ones. Data products are a newer construct in Atlan, and they map surprisingly well to ontological thinking. A data product is in a domain or subdomain, has defined owners and consumption assets, quality metrics, and SLAs. It is not just an asset, it is a semantically rich entity with contractual properties. In an ontology, a data product would be a first-class type with relationships to the concepts it represents, the source assets it depends on, and the governance policies that apply to it. Now, we should be honest here about where the edges are. Atlan's metadata graph isn't an RDF triple store. It likely doesn't support OWL reasoning or formal ontology inference. And that's a design choice, not a limitation. A formal ontology engine introduces enormous complexity, schema languages, reasoners, consistency checking that most data teams neither need nor want. Atlan provides what we might call a pragmatic ontology layer, the 80% of ontology capability that delivers practical value without requiring a knowledge representation specialist on staff. The question for almost all teams isn't, does my platform support formal ontology? It's, can I model my core business concepts, link them to real data, define meaningful relationships, and have the platform act on those relationships automatically? For that question, Atlan's building blocks, the glossary, custom metadata, classifications, propagation, data products, and the underlying graph model provide a working foundation. With the architecture understood, we arrive at the practical question: how does a team actually do this? And the single most important thing to say is, don't try to model everything at once. The enterprise ontology project that begins with a 6-month design phase, a committee of 12 stakeholders, and the goal of modeling every concept across every business unit, that project fails. It fails because ontologies are living models, not waterfall deliverables. They need to be built iteratively, validated against real data, and expanded based upon actual usage. Here's what an incremental approach looks like, grounded in a scenario we see across financial services. A bank's data mesh initiative has stalled on a semantic problem. Each domain publishes data products, but customer means something different everywhere. Retail banking means individual account holders. Corporate banking means organizational entities. Risk means counterparties, which might be individuals, organizations, or even sovereign governments. 3 definitions, overlapping but not identical. Every cross-domain analysis is a potential source of conflicting numbers. The team starts with one domain, retail banking. They open Atlan's business glossary and define 20 core terms: customer, account, transaction, product, branch, segment. They organize them into a retail banking category and glossary. For each term, they write a precise definition, not marketing language, but the operational definition that an analyst can use to determine, does this column represent this concept? They link each term to the specific physical asset in Snowflake where that concept lives. Customers links to the customer dimensions table, to the customer ID column in the transaction table, and to the retail customers dataset in the BI layer. Then they add custom metadata properties for terms like scope. Customer gets a custom attribute, scope, and they mark individual. When the corporate banking team then models their domain, their customer term gets the scope of organizational. When risk models scope theirs, they put counterparty. The shared concept has a shared name. The domain-specific meaning is explicit and queryable. Now, for automation, the team builds a playbook. When a new table is discovered in the retail schema and contains a column matching common customer identifier patterns such as customer ID, the playbook automatically links the customer glossary term from the regional banking glossary to that table or column. For bulk operations like linking hundreds of existing tables to glossary terms based on schema and naming pattern, the team can also use playbooks or Atlan's Python SDK. A short script scans the tables and column names, matches them against the business glossary, and creates proposed linkages for human review. This is how a team with 50,000 tables avoids spending a year on manual tagging. The critical insight is that it isn't a one-time project. The retail banking ontology starts with 20 terms. After 3 months, it has 35. After 6 months, cross-domain terms emerge. The team identifies that transaction appears in all 3 domains with overlapping but not identical meaning. They create a shared core entities category with the same common definitions and link domain-specific variants to it. The ontology grows from use, not from a design committee. Everything we've covered so far, glossary terms, custom metadata, classifications, propagation, data products, incremental modeling, converges on a single point, the context graph. When all of these metadata layers are connected in Atlan's underlying graph, every data asset sits at the center of a web of meaning. A single table isn't just a name and a schema. It's connected to its business concepts, its classifications, its owners, its lineage, its quality scores, its domains, and its consumers. That's a context graph. It's the ontology made operational across real data. And this is where the AI story becomes concrete. Consider an e-commerce company deploying a natural language data assistant. Business users ask, what was last quarter's revenue in EMEA? The data warehouse has 4 columns with revenue in the name: gross revenue, net revenue, attributed revenue, and GMV. Without semantic context, the AI picks one. It might pick wrong though. The user gets a number, they trust it because the AI was confident, and the number ends up being wrong. Now, put a context graph behind that AI. The glossary term revenue is defined as net revenue after returns. It links to the net revenue column in the finance schema. The EMEA filter maps to the region column with value EMEA. The AI doesn't guess, it resolves through the graph. The answer is correct, not because the model is smarter, but because the context is explicit. This isn't speculative. This is the pattern that every organization deploying AI in the data stack needs. The organizations that build semantic context now, even a partial, imperfect, 20-term glossary linked to real assets, are the ones whose AI tools produce trustworthy results. The organizations that wait for a perfect ontology before starting will find themselves years behind, with AI tools that generate confident, unreliable answers. Looking ahead, the trajectory for platforms like Atlan is clear. The building blocks already exist: graph-based metadata, extensible schemas, glossary hierarchies, classification propagation, automated workflows. The frontier is richer relationship types between glossary terms, deeper inference capabilities that go beyond classification propagation, and tighter integration with AI tools that consume semantic context. For organizations that need it, there's also interoperability with formal ontology standards. But the most important step is the one a team takes this week. Pick the domain that causes the most confusion. Define the 20 terms that matter the most. Link them to the physical assets where those concepts live. Set up one playbook to keep the linkages current. This isn't a theoretical exercise. It's the foundation of a context graph, in the beginning of an ontology that actually works. We've covered a lot of ground, from why flat catalogs stall, through what ontology and context graphs actually mean for practitioners, to the specific building blocks in Atlan's metadata architecture that makes incremental ontology modeling practical. The core idea? Meaning isn't a feature you turn on. It's a layer you build, one domain at a time. Once you have a working context graph, the next question becomes, how do you govern it as it grows? And who owns the semantic model? That is exactly what we dig into in our guide on metadata governance at scale.